Hi everyone. So this following week's lesson will be on temperature sensor. So just going through the slides, some of the lesson objectives are listed below. And what we're going to do is just connect one of the temperature sensor as well as the temperature probe. And using the temperature probe, we'll be taking temperature readings of two different liquids at the end of the experiment. So for the first part, I've included a video that talks about pasteurization, because pasteurization is closely related to food processing and food manufacturing. And I've also listed some of the temperatures for various heat treatment that is used commonly in manufacturing of foods. So this is most commonly seen in your UHT milk as well as your fresh milk that is on the cold storage area in the supermarket. I've also included some of the types of temperature devices and tools that are used in food manufacturing as well as for everyday uses. So you can see that there's a temperature gun, a digital thermometer for measuring body temperature, as well as temperature probe. We also have combination kind of devices that includes measuring of temperature as well as this humidity at the bottom left corner. In catering services, they use charts to document this temperature of cold storages as well as some of the cook chill systems throughout the day. So you can see from the circular charts on the right hand side, these are those charts that is commonly used in catering facilities. So there's also infrared cameras that is used in areas of high people density as well as in the airports to measure body temperature of people. So for the first activity, we'll be doing the temperature sensing. What we'll be using over here is a temperature sensor, a small temperature sensor called the TMP36 sensor. So you can see from the slide it says the TMP sensor, and for the sensor itself, there's 3 pins. It has 3 legs. So the pin on the far left side will be the pin that is connected to the positive end or the 5 volt. For the middle one will be to the analog input towards the Arduino board, because it sends electrical signals back to the Arduino board for, and it will be connecting the temperature sensor out like that. So the analog input will be default A0. However, you can change to any of the analog inputs pins, and you can also change the code accordingly. So what I'm gonna do is just pause it, and then I'll just fix it up on the breadboard itself. Okay, so from here you can see, as I zoom in, we have the 3 legs of the TMP sensor. They are attached corresponding to the different colored wires. So the positive one will go towards the red wire, and it will come to the Arduino board as the 5 volt, as you can see over here. And if it traces the ground, which is next to the 5 volt, it's the black wire that goes to the rightmost leg of the TMP sensor, and we have the analog inputs wire. I have used a lighter yellow wire for this. It goes to A0 on the Arduino board. Okay, so what I've done now is actually I've connected up the Arduino board itself to the computer via the USB port. And if I return to the slides, we'll just go on to the next slide. It will say go to the folder and load sketch TMP36. So I have actually uploaded some of the codes, example codes, onto the laptop itself. So we'll instruct the students to just open up the respective sketches and load them onto the Arduino software. Okay, I'll just exit this PowerPoint slide and we'll just have a look at the Arduino code. So I've got over here, it's TMP36. Just open this up. And I'll just blow this up as well. So this is the TMP36 code. It's rather short, but we'll just not go into details about this. So I'll just pop back to the slide itself. What we're going to do is I'll open up the serial monitor to get temperature readings. So the serial monitor will be this little magnifying glass on the top right hand corner of your Arduino, as shown here. I'll just go back to the slides itself. Okay, so what's next? We'll just briefly explain the analog input actually are just electrical signals that's transmitted back onto the Arduino board itself. So that will be converted into voltages, and this will then be subsequently converted to temperature in degrees Celsius, because we have actually input a formula onto the TMP36 sketch itself. So what students can do now is to just press the finger onto the TMP sensor and we'll get some readings of the serial monitor. What I'm going to do is just open up the serial monitor first. Okay, I'll just upload this, and before that we'll just select our port. Okay, so it's done uploading. So in the serial monitor now we can see that there's already readings. So what I'm going to do now is just press my finger onto the TMP sensor. Just like that. I'll just have a look at the readings of itself. So you can see that actually it's slightly going up. It's more than the previous reading. In fact, it's actually fluctuating. Just bear in mind that this TMP sensor, 36 sensor, it's a small sensor, so it's not that sensitive to actual reading. So you wouldn't be getting 36.9 degrees body temperature in exact. So probably you get around 32 to 35 degrees Celsius at most. Okay, so that's this activity. Okay, so as we'll just move on to the temperature probe. So what we're going to do now is to try using the temperature probe instead of the TMP36 sensor. So I've actually included the diagram as well. So you can see from here we'll actually be connecting up the temperature probe. So the temperature probe itself has also the 3 legs, which are 3 wires that is sticking out, similarly to that of the TMP36 sensor. However, additional components needed over here is the 4.7k ohms resistor, as well as the change of the signal input over here. We are going to use pin 2 on the digital side of the Arduino board instead of the analog pins previously used. Okay, so I've got a temperature probe over here, and as we can see, we have the 3 legs over here. One of it is red, one of it is white, and one of it is black. So it actually corresponds to the positive, the signal, as well as the negative or ground. On the other hand, we also have the 4.7k ohms resistor, as you can see over here. So you can see that actually for the 4.7k ohms resistor, it actually crosses between the 5 volt as well as the signal wire. So if I show you over on this breadboard itself, you can see that my 4.7k ohms resistor is actually crossing between the 5 volt and the signal wire as such. So we will just fix the resistor up before we put the ends of the temperature probe onto the breadboard itself. Yep, so now I've actually added the temperature probe onto the breadboard with the corresponding colored wires. So over here, like we've said, we've changed it to digital pin 2 on the other side of the board. This is because by default of the code that we are using, it is pin 2. Okay, so I've now opened up the temperature probe sketch onto the Arduino software. So we'll be using the temperature. This is also preloaded onto the student's laptop, and we'll be using this instead of the TMP36 sensor sketch. So you can see actually one wire bus over here is the pin 2 on the Arduino. So we've actually plugged into pin 2 on the Arduino. So again, we can go to this little magnifying glass over on the top right hand corner. Okay, so we'll be just opening up the serial monitor again. And you see over here it says requesting temperature. We have some of the temperature reading over here. So what I'm gonna do is just pop the temperature probe into a cup of liquid just to simulate what's gonna happen during the experiment. So we'll be getting some temperatures readings accordingly over here on the serial monitor. And again, we're gonna just measure different liquids, one hot and one cold, so you can get different temperatures on the serial monitor itself. So by specifications, this temperature probe can measure from minus 55 degrees to positive 125 degrees Celsius. So it's quite hardy in that sense. Okay, so I'd say that's about it for this week's activity. Pardon me. And we're just gonna go through the questions and answers. And just a short summary of what we've touched on. We have brought across the temperature monitoring and food manufacturing industry. We have connected up a temperature sensor as well as a temperature probe onto your Arduino, and we have measured the temperatures using these devices, measured temperatures of beverages and soups, or hot or cold liquid using these devices. Yeah, so thank you. That's about it for next week's activity. Thank you for tuning in.